So, what's up guys, how have you been? I'm really excited today to present you this specific new tutorial video which we're talking about the drainage design. We're talking about the interoperability, the workflow between Civil 3D and Autodesk InfoDrainage, how you can design digitize your catchment area and your pipe extraction from Civil 3D and export it for Autodesk InfoDrainage from hydraulic complex design. So before to begin our demonstration, we'll talking a little bit more for the small introduction theory. As I can see here, this is the Civil 3D environment. We begin here our modelizations. You send your model from Autodesk InfoDrainage for all regarding a sophisticated and completed hydraulic design, including some international standards for water design and modeling. So we are to be very long. We begin by our theory. While I'm talking about InfoDrainage, so I'm really firstly sorry because not to talking about the complete information about InfoDrainage. It's just a short demonstration about Autodesk InfoDrainage and Civil 3D. We're talking about InfoDrainage for designing a greener, sustainable futures for the water. I'm Christian Barakika, BIM AC Techno Specialist and the Water Infrastructure Expert. So what is InfoDrainage? Maybe one of subscribed or clients or professional can ask me or wondering why I'm talking about. So InfoDrainage is a full design and analysis solution with intuitive control and clear visual to deliver sustainable, cost-effective, reliable, and compliant drainage design. Why transforming it can allow professional and hydraulic engineers to improve efficiency, compliance, and control across the life cycle of the project, the water life cycle projects, because you can transforming from gray to green infrastructure, accelerate BIM workflow with a boiler and integration with a Civil 3D and the data exchange with the AutoCAD and the JS platform. A simplify regulatory compliance with the auditing tools and customers reports. So we're talking today about the InfoDrainage to Civil interoperability. We'll see how we can do it. A CAD BIM workflow for optimize city drainage, and because it was tackling from a challenge like data from a range of source, frequent small dollar rate, contradiction to data error, and non-trial and collaborative process. This will see the environment of Civil 3D and InfoDrainage. Will optimize your design in Civil 3D and create sustainable drainage solution connected with CAD. You will see everything faster the object represented. So to not be longer, you can begin our demonstration. So this is the Civil 3D environment. We design everything here and use this plugin to export our hydraulic modeling from Civil 3D create catchment area. So it's possible to import just only CAD data and import it to InfoDrainage, begin our hydraulic modeling in the calculation design completed, but we want to show the import the benefit to working with CAD and hydraulic sophisticated software like InfoDrainage. So this is a model, and after to design it, we'll import it to InfoDrainage from some other design detail and the requirement. So we begin with this model. The first of all, without begin Civil 3D project, hydraulic project, you need to import your surface. So my surface I imported from Civil 3D. I'm using a land XML. There is many methods of exporting surface or creating surface Civil 3D. There is already run, and this is, I can select, so I'm working the wall surface, so that is okay. And the other thing is, after to create it, is to go to setting, and edit drawing, and defining your categories, area and zone. I'm working with Great Britain, Great Britain. Great Britain. Yeah, okay, and apply, and so. Right, okay, for a file, we show you in use geolocation, how you can do the thing like this, importing, exploring, and explore many area in using all the type, the download the map in using S3 on Bing mapper. So I have to do this. So you have to do this. So I'm exploring some data, like exploring our line piping. So it's a card data. I'm going to open and checking in my hydraulic recent projects. So I'm going to desktop, select in Innovas technique for cell drainage, course data, and then I have my pipe outline. I'll do the same to do the same for exploring for the catchment area. Yeah, it's very important. So that's okay. That's it. Okay. So the first of all, I'll select copy, AutoCAD command cap click, and back to my project, and a cast command. Origin. Okay, so I have it, so I can add, give it a name. I can do demo for drainage. Okay, and that's you can change it every time you want. So after I'll begin by setting some things. This I must define my para network list. So I create new, go to information area, for drainage, specific space, and go to pipe, add the pipe family. I'm working with the concrete pipe internal system, and after going here is there, and I can add some para size. So I check this, click here for the same things for structure. I added the para family, so I'm working with the junction structure with frame. So I'm working with the cylindric structures E. So I'm going there, and add other para size. I'm working just for the inner diameter. And after to do this, so the next is to checking if your set pipe noted catalog, working with the matrix pipe catalog as Gabori, so as template. That's okay for me. So I can go to the pipe network and create pipe network from tools. So I define our storm 01. They select the surface, looking the surface 1, it's so pipe, on the for the pipe of that name only. Okay, so I have this options, so I can select the pipe structure SE, and here working with the concrete, working with this. So checking if your object snap setting is very well, everything is checked. And go there, snap, you have the first structure, and so going to this, and after you have this, select, we have this, we have this, and we have this. That's okay. Let's just come to finish our modelization of our pipe for the drainage systems. So we can just select our catchment area, copy, clip, go to for drainage system, past and past origin. We have it, so we're going to analyze the catchment area from object. I click for the first object, escape, and select the first pipe network structure. The first pipe network structure is there, and I go to the catchment area still only, flow segment label, just none, and go to flow path, to calculation user, and back to this and create. That's the first one. I can do the same for the all. Second, I select this and do the same, none, and there it's okay. Yeah, it's okay. Okay, so I will do the same for the all of our drainage system area. There you okay, as our all catchment area already done, already modeling. That's okay. That's what we can do after this. If we just finish our catchment area modeling, you created the inflow, the catchment area, and we've been created the pipe to transport our water from the structure inside the catchment area to info drainage to the drainage system. So after to finish the modelizations of our structure, what we can do after is to going to info drainage exporting to export to info drainage. It means you want to make this interoperability, the workflow between civil trading and the info drainage systems. You can select the location of your model. You can put a tree, the initial model, go to next. We will select the network. This, if you want, if you don't have the surface inside your info drainage, you can export your model with the surface, this surface. So in our model we have a digitized model, the same in info drainage. That's the going do not export surface. Go next. For the next, so it will allow you to make the mapping from civil 3D part and info drainage equivalent. So I can see here we have this just for civil 3D parts. So for the same diagram for the mapping for info drainage will be the same, and you can go for the structure. You do the same. From the structure we have this, and for in the front range it will be represented with this value, because this is a mapping from with civil 3D and the front range before make the interoperability and import export. So everything is okay. We'll be back. We'll be back in civil 3D after to make a complete analysis and design of our 3D model. So this is the info drainage environment. For the file, I'll explain you the detailed information about all the ribbon for the software. So I'm working with the metric model, and after I just go in here and open this and back to the sessions. I have where is trade. Okay, you see, yeah, there is some error, but we can do this. Do not. You can have this a model like this. You see, you have a model like this after to exporting and respect everything. So this is our 3D model making from civil 3D to info drainage, and this model we can begin to make some information like checking the information about the catchment area, the characteristic of each catchment area, but you do do not lose time. We just a design, not build. Checking the table. From the table, we will begin with the inflow. You can see from the inflow, you can just define some things you want to see in the table after the calculations. Here we have some change. We have the area of each catchment area, sub-catchments, the percentage of impervious. We can see here is not recommended. Then from here we can just select and put 60, the percent of impervious. We have the volumetric coefficient. From the preliminary concentration time, here we can just select for each catchment area, put 5 units. The drainage from, and this is okay. Time concentration here, you can just put a sign, okay, and here you can just change the percentage of impervious. That's okay. You can put the same for the junction, which things we want to see for the junction. You can define maybe the type of the junction, the depth option, maybe the extent nothing diameter. That for me is enough. So we can put, if you have a stormwater control, and so for the connection, which element you want to see, if it's all, so you'll have all information about here the things you want to do. After to do this before, so we have, when you select the connection pipe, it gives you the table of each characteristic of pipe, the slope inside the pipe according for the 3D terrain digital model, MNT, 3D terrain digitized model, civil 3D, and the mining coefficient, the diameter, the upstream, and so on. And after to do this, you need to create, you need to import your surface. So we have already a surface inside our InfoDrainage. So this is our surface. And after we can just go to perform our analysis. There is many kinds, many standards for designing and calculate a drainage area system, the drainage sustainable, and so we define our rainfall manager. You have the IDF curve. I'll go FSR. So I define. I put the name run one, and define the time of running. I put for a minute, and the ratio is 1.4. Define the summer, and the period of return. I'm working with 2 periods of return, 2 years and 5 years. And the storm duration, the duration of the storm, I select by default, and I'll click OK. So I'm going to preliminary size. Preliminary size, I give you some first result. I have it, the maximum travel in time, and I will select the rain, my standards, my method of dimensions, and I'll apply, click OK, and go to design reports. You can have some information about, but it's not all. We have some information here, so we need to go to analysis and create the analysis criteria. We must select the method of calculation of our stormwater, our drainage systems. Look like here. And to validate, you can validate. You see here, you need to change it. Timing of travel. Put 30 minutes. Click OK. So go again. Here, validate. Everything is okay. So you need to run analysis. After to run analysis, it will give you some first. Proposal information. We do here. You have this max of 4. There is some switch inside some usages for capacity for excedence. You can see here there is the capacity of flow and the max flow here. It means here you have for a capacity for exceedancy. So if you want to have some information about the critical return period, everything is okay. We can working here with, but the software will give you some correct dimension of the size of of our drainage pipe systems. For critical storms, you have all information about this. You can see for all storms, you have here some surcharge because you have max depth, you have the chart, the velocity, and the flow capacity, the max flow lit by second. You have all information. You can explore it for here. So we can just go back to here, and we have all information here about the upstream. The diameter is suitable, it's okay. So I must select parts, that's okay. I must select my parts, select parts first, and do this. Okay, this is my part. You can see your profile view of your drainage systems. You have here, we have a pipe inside the structure for collecting water in each catchment area. You can begin here. Next, you see here the rational method of calculation, the period return. You can see here for the preliminary size design and previews. So that is okay. You can see here, this is the correct diameter that the software gives you to do not make accidents or working in the extreme condition for design. We have put a preliminary 100 millimeter, but the correct to not make a flood inside the drainage system. For each pipe you need this. It's according some quantity of water it transported. We have all this correct diameter after the designing our drainage complex system. This is the data, and the value will imported from drainage from InfoDrainage to civil 3D. Finish. Okay, we have all information. The proportion depth, this is the correct proportion depth for the pipe, the total area, the impermeable area of each catchment area, the full bore velocity, the capacity, and the flow. That's okay. I just done my design, my calculation. So what I can do is just to save these things here and go back to the civil 3D. This is my civil 3D model. What I'm doing is to just select this, and I selected the similar, I delete, and I put the same here, similar, I delete. I put for the pipe similar, I delete. So I'll be back, export the model, and selected our model. We have this digitized model, and go there. We have this. Next, we have everything here from the, and we're wearing. This is easy for our first modeling, but we can export the exact. For example, this, because I'll go back here. This is okay. Okay. Select. Already selected. Okay. Voila. See, that's okay. This is our, after to make calculation from civil 3D to InfoDrainage, this is the minimum diameter and the maximum diameter inside the drainage system. Yeah. I select some things here. What's the problem? For the junction is the same. We have the civil 3D part, and selecting for the cylindric Yeah, that's okay. Everything is okay. Connecting, mapping, we have all of this. Okay. So from Civil 3D, everything is okay. After to export our model, so you can select inside your model here and click, for example, gravity calculate, resizing the pipe. For example, if you want to resizing your pipe, click analyze this. You can see here you have some results. This is charge. This is some pipes for that Civil 3D give you, and so you can view the profile. If you want, you can create to have the profile have been created here, and so there is many things. For our demonstration, we can do the same. We can export everything. We have every information because we have every model. But this was the purpose of this demonstration about the workflow between Civil 3D and the InfoDrainage. How you can resize your pipe from Civil 3D from InfoDrainage after the complete design and analysis. It's the first time for me to make this tutorial video about the Autodesk infrastructure for drainage, sustainable drainage system. But don't be stressed and frustrated. I'll be back with some more important and insightful content about this amazing software for hydraulic engineers and for civil engineers, about how you want to design, detailing, and present a good sustainable infrastructure design system. Thank you so much, and see you later. Bye bye.